right, we're going to just be using the same strategy, but now we're going to include variables in the radicand. Simplify whenever possible. So we're going to be looking for prime factorization and having perfect square factors in the radicand. So when I multiply root 3 times root x, what I can do is I can write it under one radical, and that would be the 3 times x. So I would just multiply the radicands. And I could write this as 3x. So that is the square root of 3x. B, I'm going to take a look, and I just want to draw your attention that this is actually a monomial times a monomial. Before I dive in, I'm just going to look at my radicands, 2x and 6. What I recognize is 6 has a factor of 2. So 2x and 6 have a common factor. So I'm just going to maybe work that to my advantage here. Going to be multiplying these two radicals. Going to multiply the coefficients. So negative 3 times 4 is negative 12. Now, when I'm going to multiply my radicands, I'm going to say, well, that's 2 times x, and 6 is really times 2 times 3. So I could rewrite this as negative 12 times 2 squared times 3x, just rearranging it. So I'm going to try to put the perfect square factors together, and whatever is left over I'm going to put together, but I'm going to put the coefficient in front, just to prepare how we write polynomials. So this is negative 12, the square root of 2 squared, times the square root of 3x. So this would be negative 12. I can easily simplify the square root of 2 squared, and that is 2. And the square root of 3x, it just remains the same. I'll multiply those two integer numbers, so that would be negative 24 times the root of 3x. All right. So I'm going to do number C. Well, C seems very similar, but now it's a monomial. Do you see the monomial? Times a binomial. So I really need to do two multiplications, 1 and then 2. So 4 root 3y times 4 times the root of 3y times the root of 5y. So really, this is going to be, I'm going to multiply the coefficients, and there's an imaginary coefficient in front of the root of 5y. We have 1, so 4 times 1 is 4, times, now 3y times 5y. Now, do you see how there is a perfect square factor of y squared there? So I'm going to combine that later. But now I'm going to go into that green multiplication for the root of 3y times root of 6. I'm going to multiply my coefficients, and when I do that, that creates negative 8. I'm going to multiply my radicals. Now, just looking at these radicals, they're kind of nice because 3 and 6 share a common factor of 3. So I'm just going to write this as 3y times 2 times 3. So I may need to reorganize this. So I have, in essence, I have it in prime factored form. So I'm just going to reorganize it so my factors are perfect squares. So 4, and I'm going to split this up. Well, we could probably split this up right now. I'm going to split this up into y squared times 3 times 5. We get y squared from this factor of y times that factor of y. The leftovers are 3 and 5, so that creates another radicand. I feel like we've done this quite a lot. So negative 8. And I'm going to take a look. Underneath that radicand is 3 and 3. So I'm just going to create the square root of, 3 squared times 2y. there. Now, maybe that wasn't the most elegant way, but sometimes we don't do things the best way. So I'm going to simplify the square root of y squared. So that's just simply y. So 4 times y times the root of 15 minus 8 times the root of 3 squared times the root of 2y. So this would be 4y root 15. Simplify nothing from the first term. Now let's go in the second term, 8, and I could simplify the square root of 3 squared simply as writing it as 3 times the root of 2y. So here we have it. We're almost there. This is quite a long adventure. So this is 4y root 15 minus 24, the root of 2y. That's it. Can I combine these radicals? No, because the radicands are in the simplest form and can't really factor them. So perhaps I'm just going to go straight to G. And this will be our last example. So 5 root of m minus 3. So this is a binomial square. Please be careful with this one. I mean, if I really wanted to test if somebody knew how to multiply radicals, I would actually give them a question almost exactly like this. So what we're going to do is we're going to multiply a binomial with a binomial. So I write it out. By the way, that's what the root of, that's what 5 root m minus 3 squared looks like. It's the factor times itself. Please do not square right away. So I'm going to have to do this multiplication. 5 root m times 5 root m is, I'm going to multiply the coefficients. Now the root of m times m is going to be m squared. Perhaps you already knew that. That would be good. 5 root m, now I'm going to complete that second multiplication, times negative 3 is negative 15 root m. Well, I'm done with that first term. Now let's go on to my second grouping of multiplication. Negative 3 times 5 root m is going to be negative 15 root m. Now the second multiplication that we're going to do with the first term of negative 3 is negative 3 times negative 3, which creates positive 9. So it's all good. So now I'm just going to simplify. This first term simplifies to 25. The root of m squared simply is m. If I notice, now negative 15 root m minus negative 15 root m, so that is actually like, because the radicands are the same, m and m, and the indexes are the same, that they're both square roots. So this would create negative 30 root m. Last but not least, we have the last term of 9. And that is my simplified expression.